Hi friends, today you will learn the role of the parser. Generally, the parser is the second phase of the compilation process. The another name for the parser is called as the syntax analysis. The first phase of the compilation is called as the lexical analysis. That lexical analysis takes input as a high-level language or called as a source program and convert these high-level language into tokens. These tokens are given to the parser. Then the parser once again requests for the next token by invoking the get next token function. Then the lexical analyzer will invoke the next instruction related tokens to the parse tree and the parser, and the parser will construct a parse tree based on the tokens generated by the lexical analyzer. So generally the parser can be defined as, for the grammar, G is a program that takes a string of tokens as an input and produces a parse tree as an output. If the string is generated by the language, otherwise it should report an error. Both the lexical analyzer and the syntax analyzer and the semantic, all the rest of the phases are connected to the symbol table. Once the phase is successfully completed, the results are going to be stored in the symbol table. So these parser is going to be further divided into two types of parsers. One is the top-down parsers and the bottom-up parsers. The top-down parser is going to be build the parse tree starting with the root node and work down to the leaf node. That means that whatever the grammar symbols that we have, we are going to be deriving a string from the start symbol to the leaf node. When we are going to talk about the bottom-up parser, the bottom-up parser will invoke the string derivation from the leaf node to the root node. So these are the subclassifications of parsers. So both top-down parser and the bottom-up parser. Here LL of 1 means reading a character from left to right and then leftmost derivation. And the bottom-up parsers we have LR parsers. LR parser means reading a character from left to right and the rightmost derivation. And we have the shift reduced parser, that's also available in the bottom-up parsers. So generally the output of the parser is nothing but a parse tree. Generally, the parse tree is also called as a derivation tree or syntax tree. It is used to represent the derivation of a string from the grammar G. So that means that a parse tree. The main properties of a parse tree is the root is labeled with a starting symbol. All the leaf nodes are always represented with the terminals. All the internal nodes or interior nodes are denoted with the variables as per the grammar symbols triple representation of the grammar G in the form of variables, terminals, production statements, and the start symbol, that is nothing but G is equal to VTPS. Suppose a node A has a children's x1, x2, and so on xn in the parse tree, then the grammar must and should be have the production related to that parse tree is A tends to x1, x2, and so on xn. So let us example consider the parse tree. So these are the properties of all the parse trees, whatever I said. For example, if we consider the grammar G, the production rules are S tends to S plus S or S star S. S tends to A or B or C. So these are the two productions available in the grammar G. So as per if I given the string to derive the string W equal to A star B plus C. So what is the first starting production S? S can be replaceable as S plus S. So either this one or this was possible. First I have taken as S tends to S plus S. So once again S is going to be derived. In the second step I am going to be extending that S is going to be representing as S star S in the second step. In the third step, so S is going to be further divided into either A, B or C as per the string derivation A star B plus C. The second part is going to be divided into the first S is going to be replaced as the leftmost S is replaced as A, and the middle S is going to be replaced as B, and the last S is going to be replaced as C. So that means that I have derived the string A star B plus C. So in this manner, if you are going to be construct parse tree for the given string W based on the production rules in the grammar G, if we construct a derivation tree, and if we that construction of derivation tree, that may be more than one derivation tree, in such case then the grammar is said to be ambiguous grammar. That means that the string is derived from the grammar G, and if you have the possibility of constructing a one or more parse trees. One or more parse means there may be a multiple existing of rightmost or leftmost derivation tree, or for some strings generated by the grammar only. How we are going to be generating such type of trees? So example, let us consider another problem. Here the production statements are x tends to x plus x or x star x or x or a. Whether it is ambiguous or not, that should have to be checked. So now I have taken the minimum string to derive the string is a plus a star a. This is the minimum string I am going to be deriving. As per the starting symbol, x is going to be taken. X is going to be treated as x plus x. Now I am going to be deriving the bold color format of the derivation. I am going to be deriving that a plus a star a. X is going to be replaced as x plus x. So once again x is replaced as a, and then x is going to be replaced as once again x star x. This x is going to be replaced as a, and the next most handle is a x. X is going to be replaced a plus a star a. This is the one way of parse tree construction. Another way of parse tree construction for the same grammar, by using the same grammar, by using the same for the same string, if I am going to be construct, see here. If I am going to be constructing a parse tree for the derivation x tends to x plus x, first I have taken x is replaced as a, and x is replaced as once again x star x, x is replaced as a, x is replaced. This is the one of the parse tree. And I am going to be constructing another type of derivation. Instead of x plus x, I am going to be treated as a x is replaced as x star x. The first x is going to be replaced as x star x. After that, this x is going to be once again subclassified into x plus x, replacement production. So this x is replaced as a, and this x is replaced as a, and this x is replaced as a, same a plus a star a. Both are to be different parse trees. So that means that if you compare the both parse trees set it in parallel. For example, I am going to be maintaining the both. So meanwhile here I am trying to be maintaining. See here. So here x plus x I am going to be replacing one possibility parse tree, another possibility I am taking as a first possibility x star. Both are treated as different parse trees. That means that when we are going to be constructing a parse tree for a grammar G, if we construct one or more parses, then that grammar is called as a ambiguous grammar. Another way. So this way of construction is called as a parse tree. Thanks for watching.